Welcome to my channel once again. Now we are going to discuss a topic called axial flow turbine. For centuries, waterfall with a large water drop or head has been used for converting the incipient potential energy to kinetic energy. The basic mechanical principle that if a fluid with a large kinetic energy contents is allowed to hit a set of blades free to rotate, certain amount of shaft work can be extracted from the passing fluid has been known for a long. This energy is available in the form of rotating shaft power and can be used for various purposes. Wind turbines also use naturally available wind kinetic energy to extract power out of it. It was also understood that for a gas turbine engine to go on an aircraft, it must be compact in size and must weigh as less as possible. This requirement translates to the need for a turbine which produces high energy extraction per unit mass or energy density of gas it is working on. The graduation of gas turbine based engines to jet engines in all its variants come from the basic fact that the working fluid, that is air, enters and exits almost parallel to the axis of the engine. Thus gas, if it contains sufficient residual energy after the turbine, can be excited through a jet nozzle to create a direct engine jet thrust. Aerothermodynamics and basic theories of axial turbine. So here you can see stator. Here we can see stator, rotor. A combination of stator and rotor will be considered as a stage. Flow comes from the combustor with high internal energy T01, P01, Ca1 and is made to go through the stator with a large part of its internal energy is converted into kinetic energy. The transfer of energy occurs in rotor as high kinetic energy flows impinging on the rotor blade is also made to take huge flow turning through the passage between the blades. Turbines use fundamental principle for making blades rotate to create mechanical rotation are called impulse turbines. The amount of energy given up by passing gas is decided by the energy level of the incoming gas and by amount of turbine executed by the gas in the bladed passage. The energy transfer occurs as per Newton's law of motion so that rate of change of momentum of the gas is in the direction in which the blade rotates. Development of gas turbines, especially for aircraft engines, required even more energy to be transferred per unit mass flow than is possible with impulse turbine. This was achieved by making the flow also accelerate through the rotor blades by making an expanding and converging curved nozzle passage in addition to the large turning. Jet effect of the flow exiting from the rotors create a reaction as per Newton's third law of motion. This reaction force, or rather it is component along the plane of rotation, adds to the angular momentum created by the impulse effect of the gas. These turbines are called reaction turbines. The gas turbine in aircraft engines are reaction turbines. Impulse turbine, high energy flow is first accelerated and made to impinge on the rotor blade with high momentum and then made to take huge turn through the passage between the blades. Reaction turbine. The flow is accelerated through the rotor blades by making an expanding, converging, curved nozzle passage in addition to the large turning. Jet effect creates a reaction as per Newton's third law of motion. In the impulse turbine described earlier, V2 is equal to V3. In reaction turbine, V3 is greater than V2. In the aircraft gas turbines, the exit Mach number from the starter nozzle M2 is equal to 1.0. On the other hand, the relative exit Mach number from the rotor M3 real is V3 by A3 is less than 1. The work done in gas turbine may be increased by increasing entry temperature T01. Work done in gas turbine can be given as HTH is equal to U of CW2 plus CW3. Degree of reaction through a stage provides the split of acceleration between the rotor and stator. So degree of reaction can be given as H rotor divided by H rotor plus H stator. That implies H rotor by HT is equal to V3 square minus V2 square by 2HT. Total to total efficiency of gas turbine engines can be given as eta of OT, that is total efficiency of total gas turbine engine, can be given as H0T divided by H dash of 0T is equal to eta of T H dash T by H dash of 0T. That implies eta T into 1 by 1 minus C3 square by C3 power 1 by 2 of T3 by T3. The parameters with suffix 1 refers to isentropic process in the turbine. With this, we will be winding up the video. Thank you. If you like the video, please do like, share and subscribe.